Okay, so what we're going to work on now are some number word problems, algebra applied to word problems. So I've got four of those for you to do. We will do stop and start. Now you have seen each of these concepts already, but we're going to do a deeper dive, delve into these and really try to pick them apart a little bit. So let's do stop and start with the first question here, the one at top. Four times the sum of a number and 5 is 32. Find the number. Go ahead. Okay, so um, let's straighten it out and try to write an equation for this. And what I notice, underlining the important parts, 4 times the sum of a number and 5. That's clearly an important part. I love to underline. I've mentioned this in other videos, but I've been amiss or remiss or whatever, and I haven't actually done the underlining. I'm doing it now. And then is 32. So this is clearly important. 4 times the sum of a number and 5, and the is 32. Find the number. How do I write an equation for that? Well, it's 4 times the sum of a number and 5. It's 4 times what? 4 times the sum. So to get the sum, I have to group it together. And that's what I do here with the parentheses. Parentheses are grouping symbols. So that's 4 times the sum of a number and 5 is 32. Now, I put up the whole solution at one shot because all you need to do here is to distribute. 4 times n is 4n. 5 times 4 is 20 is 32. Subtract 20 from both sides. 4n is 12. Dividing by 4, n is equal to 3. Generally speaking, this isn't 100% true, but it's generally true. When you get, don't worry about my dogs barking there, sorry. Generally speaking, when you get the equation, it's not difficult to solve. The tricky part is setting up the equation. So that's what we want to work on here. All right, you try the next one. And I took the liberty of underlining the important parts for you. 5 times the sum of a number and 2. This time I add a little step. Increased by 2 is 52. 2's running amok in this problem. Wild all over the place. All right, this time you begin. Go ahead. Stop and start moment. Okay, so 5 times the sum of a number and 2 is 5, and then in parentheses n plus 2. But then it's increased by 2, so I have to put an additional plus 2 here, is 52. Distributing the 5n plus 10 plus 2 is 52. That means 5n plus 12, because I want to get these 10 and 2 on the same side, do the same operation. That's 12 is 52. Subtract 12 from both sides. 5n is 40. 52 minus 12 is 40. Dividing by 5, n is equal to 8. So that makes the number that I was looking for. Okay. Let's now go to the next slide, which says find 4 consecutive even integers whose sum is 44. And let's go through this whole problem beginning to end, and then we'll have you guys do a little bit of work on it, okay? All right. So it says 4 consecutive even integers. I underline that because it's important. And then whose sum is 44. That means they add up to 44. Well, if there's 4 consecutive even integers, there's a first integer, a second integer, a third integer, and a fourth integer. And, you know, we did do these earlier in the year. Like, pick your favorite even number. Like, I don't know what mine is, but maybe, I guess maybe 14. I kind of like 14. So to go from 14 to the next even integers, to go from 14 to 16. So I went up 2, and then to 18, which is up 4 from 14, and so on. So that's why I have n plus 2, n plus 4, and n plus 6. Again, we did talk about this even before the first test. So if I take the first one plus the second one plus the third one plus the fourth one, I get 44. Well, it says here that the first one is n, the second one is n plus 2, the third one is n plus 4, and the fourth one is n plus 6. And altogether, they got to add up to 44. So 1n plus another n is 2n, plus another n is 3n, plus another n is 4n. Get 4n. And then, grouping together, my 2's, 4's, and 6, more same size, same operation stuff, that adds up to 12, is going to be 44. And like I said, once you get these equations, they tend to be pretty easy to do. So I subtract 12 from both sides. 4n is 32. I divide by 4, and I get n is 8. So if the first one's 8, the next one's 8 plus 2, which is 10, and then 8 plus 4, which is 12, and 8 plus 6, which is 14. And there are my correct values. Okay? That's a fundamental and a basic one. The next one, a little bit more challenging, but I do help you out with some underlines. Go ahead. Do a little stop and start on this guy, and we got one more after him, and we'll see how you do. Go ahead. All right. So, first integer is going to be n. Now, this says just consecutive integers. So that's like if I pick my personal favorite integer, which is 3, the next one is not 3, it is 4. And you go up not 2, but you go up 1. So the next one's n plus 1. And it says find 3 consecutives. So the next one is n plus 2. That's the basic easy setup part. Now we get a little more challenging. Find 3 consecutive integers such that 3 times the first plus the second and twice the third is 65. And I find that it can be very helpful to just rewrite what's underlined right here. And then focus on just a piece of it. Focus on just the part that says 3 times the first and write an expression for that. Well, 3 times the first would be 3n. Now focus on this part. How do I write the second? Well, that's n plus 1. And how do I write twice the third? Well, that's 2 parentheses n plus 2. Did similar questions a few minutes ago. And then equals 65. So there it is. 3 times the first is 3n. The second is n plus 1. And twice the third is 2 times 2n plus 2. Remember, you always have to group the n plus 2 together when you do twice the whole third, not just a piece of the third, the whole third. Equals 65. And as we said, this now is a standard looking kind of multi-step equation where you're going to have to distribute and then do same side, same operation. So first I distribute, and on the right-hand part there I get 2n plus 4. Now I do same side, same operation. Altogether I've got 6n plus 5 is 65. Subtracting 5 from both sides. I know I didn't show that step, but that's what I did. You can conclude it because there's only a 6n left on the left, and 65 minus 5 is 60 on the right. Divide by 6, n is equal to 10. So that's my correct answer for that. And what does that mean the numbers are? The numbers are 10, 11, and 12, because 10 plus 1 is 11, 10 plus 2 is 12. So there are my correct solution. And I would say on a scale of 1 to 5 in terms of difficulty, this is about a 4. So if you're there on this, you're doing really, really, really well. Keep up the great work. Now let's do one more. Go ahead. Little stop and start moment here. Okay. So first integer is n. Now these are consecutive odd, and consecutive odd can be tricky. A lot of students want to write n, n plus 1, n plus 3, and it's wrong. The reason it's wrong is pick your favorite odd number. I'll go with 3 again. What's the next odd number? 5. How do I go from 3 to 5? I go up 2. How do I go from 3 to 7? I go up 4. So in other words, whether it says consecutive odd or consecutive even, it's the same exact setup. N, n plus 2, and in this problem, there's only 2 consecutive odd integers, so I don't do any more. But if it said third integer, it'd be n plus 4, fourth integer, n plus 6, and so on. All right, so I have everything important underlined, and I like to put that into a word phrase. 2 times the first plus 5 times the second equals 129. So I write 2 times the first as 2n, and 5 times the second as 5 parentheses, n plus 2. And we know that equals 129. I have to distribute for that parenthesis there. The 2n is going to remain. I didn't do anything with that. 5 times n is 5n. 5 times 2 is 10. Equals 129. 2n and 5n are 7n plus 10 is equal to 129. Subtracting 10 from both sides. 7n is 119. Dividing by 7. N is equal to 17. So the first integer is 17 and the second integer is 19. All right, this leads us off at lesson 13, and that is where the next one will pick up. Have a fantastic day. Don't forget to do your homework.